Hello students, previously we have learned about Earth's motion as well Moon's motion. There are two types of Earth's motion, axial motion and orbital motion. What is Earth's axial motion? Earth rotates on its tilted axis, and to complete one rotation on its tilted axis, Earth takes 24 hours. And what is Earth's orbital motion? Earth revolves around the Sun on its elliptical orbit, and to complete one revolution around the Sun, Earth takes 365.6 days. What are the effects of these Earth's motions and Moon's motions? Today we are going to learn that. And what are the effects of these Earth's motions on Earth's surface? The combined effect is a season occurs on Earth's surface. And one more effect, day and night occurs on Earth's surface. The part of the Earth's surface receives sun rays experiences daytime, and at the same time another part of the Earth's surface does not receive sun rays experiences nighttime. The speed of rotation also affects on the speed of wind. Due to rotation, winds and ocean currents deflects to the right in the northern hemisphere and to the left in the southern hemisphere. That means the Earth's rotation affects on the movements of water in the oceans. The tides are deflected due to the rotation. The rotation of the Earth allows the gravity from both the Sun and the Moon to cause tides. That means the gravitational force of the Earth, the Moon and the Sun affects on the occurrence of tides. And today we are going to learn that how the gravity of the Earth, the Moon and the Sun affects on the occurrence of tides, and other factors also which affects on the occurrence of tides. Let us see. And now take out your textbooks and turn page number 9, third chapter, tides. First, observe the following pictures and answer the questions given below and discuss. First, we will observe the given photographs, figure number 3.1a and figure number 3.1b. First question, do the above photographs show the same place or different places? The above given photographs shows the same place. See, these are trees and part of a hill. In this picture also you can see this is a part of hill and same heights trees. Next question, observe and note the spread of water seen in both the photographs. So you can see in figure number 3.1a, water level is high than the water level in figure number 3.1b. And see the spread of water in figure number 3.1a. Sea water is very close to the coast, and figure number 3.1b, sea water is far away from the coast. Next question, what is this natural event called? The cycle of rising and falling of the surface of bodies of water like oceans. This natural event is called tides. High tides and low tides. When a water level is rising is called high tides, and water level is falling is called low tides. Now see geographical explanation. Both the photographs show the same place. If you stay near the coast for some time, you will realize that the sea water is sometimes very close to the coast. You can see in the figure number 3.1a. While at other times it is far away from the coast. See in the figure number 3.1b. We call these movements of the sea water tides. Barring a few exceptions, all the coasts on the earth experience tides. High and low tides are natural phenomena. Let us try to understand the scientific reason behind these natural events. Tides are movements of sea water occurring daily and regularly. The level of sea water changes after a specific period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. For example, if you are near the coast of sea and you experience high time at 8 a.m., you will experience low tide after 6 hours, 12 minutes and 30 seconds. That means you will experience low tide at 2 past 12 minutes and 30 seconds. And next high tide you will experience after 12 hours and 25 minutes. That means next high tide you will experience at 8 past 25 minutes p.m. And thus, after every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. The regularly occurring events appears to be quite simple and natural. However, it is directly related to the sun, the moon and the earth and the gravitational and centrifugal forces that interact between them. Now try this activity. Keep a small stone or a chalk piece or a pencil on your notebook and move the notebook from left to right with some force. Now I will keep this pencil on notebook and will move the notebook from left to right with some force. Just observe what is happening. The pencil falls towards the right. And now look at this container filled with water. This container has no handle, but I can whirl this container. Just observe the movement of water inside in the container. We observe we can see the water will swirl around, forming a bulge at the sides and depression in the center. The bulge of water aside, and you can see the water will swirl around, forming a bulge at the sides. Look at bulge at the sides and depression in the center, and the depression in the center. Now fill the mixer jars with water and switch on the mixer. Observe. Do this under the supervision of parents. And now look at this mixer, and I have filled the water in the container And now I will on the switch of a mixer and we'll observe what will happen. The water will swirl round, forming a bulge at the sides and depression in the center. Observe a fan and a slingshot while they are moving. Let us observe a fan. Look at the fan. Blades of the fan moving around the center of the fan. The blades acts away from the center of the fan. The concept of a centrifugal force can be applied in the rotating devices such as a fan. Take half a glass of water, slowly move the glass in one direction in circular fashion. Observe what happens to the water. Look at this glass. I have filled water in the glass and I will move the glass in one direction in circular manner. And I observe that a bulge of water show at the sides of the glass. Look at this bulge of water at the sides. Observe what happens if you whirl a keyring around a finger. When we whirl keyring around the finger, one can see the things that attach to the keyring will move around the finger. And now can you tell? On the basis of the questions given below, discuss the result of the activities listed above. According to these questions, we have noted our observation points. Just see which forces could be operating in activities listed above. Look at this figure number 3.2. Girl moving a notebook with force. We have done this activity. We kept a pencil on the notebook and we moved the notebook from left to right with some force, and we have noted that pencil falls towards the right. In this activity, we have noted that gravitational force operating. In figure number 3.3, by moving the glass with water, we have done this activity also, and we have noted that the bulge of water keeps aside of the glass. And in this activity, centrifugal force operating. And look at this figure number 3.4, girl whirling the keyring. We have also done this activity. While moving the keyring around the finger, we have noted that all the things that attach to the keyring also moving around the finger. The centrifugal force operating in this activity. In which activities did you find the centrifugal or gravitational force was greater? And we have found, after the completion of these all the activities, gravitational force was greater than the centrifugal force. Now we will see geographical explanation about these activities. In all the above activities, the effect of the centrifugal force is visible. The centrifugal force acts in the direction opposite to the gravitational force. Centrifugal means going away from the center. You must have experienced it too. At the local fairs, if you sit in a Ferris wheel, your seat spins and leans outward away from the wheel. This also is an effect of a centrifugal force. Centrifugal and gravitational force. Due to its rotation, the earth gets a type of power or force. This force works away from the center. It is called centrifugal force. See figure number 3.5. Look at this figure number 3.5. Centrifugal force and gravitational force. See how centrifugal force acts away from the center. Look at this arrow. And gravitational force acts towards the center. Look at this arrow. Due to this force, any object on the earth would be thrown into the space. However, the gravitational force is working towards the center of the earth at the same time. This force is many times greater than the centrifugal force. Hence, any object on the surface of the earth remains at the place where it exists. And today we are going to learn that how these forces, centrifugal force and gravitational force and other factors that affects on the occurrence of tides. We will see tides. Tides. The following factors are responsible for the occurrence of tides: the gravitational pull of the moon and the sun as well as that of the earth, revolution of the earth around the sun and the indirect revolution of the moon around the sun, centrifugal force generated due to the rotation of the earth. So these are the factors that affects on the occurrence of tide. The moon is closer to the earth than the sun. Hence, its gravitational force becomes more effective than that of the sun. Tides occur due to the relative positions of the moon, the sun and the earth. A place on the earth's surface located at the opposite point of the place experiencing high or low tide also experiences high or low tide respectively at the same time. This is a result of the centrifugal force. See figure number 3.6 and try to understand the location of high and low tides on the earth's surface. Look at this figure number 3.6, occurrence of tides. This is the earth. This is the moon. Look at the relative positions of earth and moons. A place on the earth's surface located at the opposite point of the place experiencing high tide or low tide at the same time, and this is the result of centrifugal force. For example, when there is high tide at 0 degree meridian, the 180 degree meridian also experiences high tide. If you are here, just consider this is a 0 degree meridian and you experiences high tide. At the same time, 180 degree meridian that lies exactly opposite side of 0 degree prime meridian will experience high tide. And the meridians that are at right angles to those having high tides will experience low tide at the same time. If it is a high tide at 0 degree and 180 degree meridians, then at which meridians will low tide occur? Just consider you are here on 0 degree prime meridian and you experiences high tide. At the same time, 180 degree meridian that lies exactly opposite side of 0 degree prime meridian also experiences high tide. And as we know that the meridians that are at right angles to those having high tide will experience low tide. that means 90-degree east meridian and 90-degree west meridian. These meridians that are at right angles to those having high tides, 0-degree prime meridian and 180-degree meridian, having high tides. At the same time, the meridians that are right angles, 90-degree east meridian and 90-degree west meridian, will experience low tide. Next time, we will learn types of tides.